I was thinking about this. I think it was mentioned earlier. This is now 20 years of JavaOne. And so I was thinking back to what I was doing 20 years ago. And in fact, exactly 20 years ago this month, I was packing my things and getting ready to move from Europe to come here to San Francisco in order to work for a small startup, which was called JavaSoft. Some of you might remember it. It was became a part of Sun Microsystems. And since then, the world has changed in so many ways. I think it's really amazing to look at the phenomenal growth that Java has had, and also what a profound impact it's had. And what I'd really like to do is to thank all of you, because without your efforts, without your embracing Java, and without your making it better, Java would not be what it is today. So the world changes a lot. I think one of the things that has really been a key to Java's success over the years is starting out with a very keen sense of the philosophy behind it. And some of these things were really there from the beginning. In fact, they're all there from the beginning, but some of them only really became apparent over time. And so I think this is one of the things that we want to continue to bring forward. Over the years, we've continued to make sure that the JDK library has a very rich set of APIs in order to make your lives easier. We focused on security, quality, performance, and scalability. And then we tried to also listen to you as developers and understand what do you need in order to be more productive. And how can we, at the same time, balance that with ensuring compatibility so that it's easier for you to move forward. And finally, we've tried to do this in a way that has been more and more open and transparent as we've gone along, doing design and development in the OpenJDK community together with all of our partners. The world has changed a lot in 20 years, and Java continues to evolve with it. The cloud has changed the world. DevOps has changed the world. And a lot of new technologies have come along, like containers, in order to help developers be more productive. Now, we want to make it easy and convenient for developers to use Java with containers. And so to that end, I'm very pleased to say that we will soon be distributing the Oracle JDK with Docker. So we want to meet developers where they are today. We want to make Java a first-class citizen for Docker, and we want to do it with a distribution model that makes sense. OK, I'm always very pleased to share interesting stories of how people are using Java in order to succeed in running their businesses. One example I came across recently is a company that I'm sure needs no introduction. I'm sure you've all heard of it. Ladies and gentlemen, please give a warm welcome to Masahiro Yoshioka-san from the IT Solution Division at Mazda.
Thank you, George.
Hi, and welcome to JavaOne, and thank you. I was recently over and visited Yoshioka-san in Hiroshima in Japan, and he showed me around the facility there. So tell me now, Mazda has a large and complex business. Can you share with us some of the areas where you guys use Java?
OK. Supply chain management process, cost calculation, and manufacturing process.
OK. So can you tell us a little bit more about the ordering and cost calculation areas?
OK. Regarding the cost calculation and the global ordering system, the Mazda migrate from the legacy system to the Java applications. And the global ordering system and the cost calculation system have the same characteristics and the different characteristics. Regarding the same characteristics, both systems is a mission-critical systems. Regarding the different characteristics, cost calculation system is a batch-based and rewrite system. The ordering system is an API-based real-time systems.
OK, so these sound like fairly universal problems. I'm sure there are a lot of industries, a lot of companies that have similar kinds of things.
OK.
One of the things I found really interesting when I was over and visited you and showed me around was the way that you guys have actually been using Java on the assembly lines, like the one that we see in the video here. Can you tell us a little bit about how you're doing that?
OK. I explained Mazda's vehicle manufacturing briefly. Mazda have a main plant and a parts plant. Main plant was stamping, body, paint, final assemblies. Parts plant are the engine, axle, transmission, and so on. This video shows the engine, axle, final assemblies. The Mazda's factory is a mixed production. The Mazda produced multiple models in the same lines. The worker sees the data in the display and the paper and choose the parts and work. And the system creates the data for the worker, and the system creates the data for the factory machine, and factory machine includes the robot.
Okay. That's really cool. So overall, what's your impression of Java and how it's worked for your business, and how does it look going forward?
Okay. Now, Mazda's IT division have a new IT strategies. In the new IT strategies, Mazda IT will achieve the harmonize the aggression and the defense. Aggression is data innovation and the challenge to the new areas. And the defenses is system development, maintenance, operations for the business continuity. And the Java point of view, regarding the aggression, the Java is innovative. And the Java provide and will provide the new function like a Lambda, Stream API, Project Jigsaw, that architect and the developers want and need. And the Java is the most popular language, and the largest number of the developers use Java in the world. And the huge number of the Java community support Java progress. That is evidence that Java is progressing continuously. That's a very, very important point that a company like a Mazda choose Java and continue to use Java.
Okay, thank you very much.
Thank you very much.
Wonderful. Okay, thank you for that very interesting story of how Mazda is using Java. I think that was really neat to see, and I'm sure you all want to go out and buy one of those Miata Roadsters now that you've seen how they're using Java in its production. Of course, Mazda is a large and complex global entity. It's an enterprise that's existed for many, many years, and so it's probably not that much of a surprise for us that they're using Java pretty extensively. I thought it could be interesting also to look at sort of the other end of the spectrum. When we look at a completely different kind of business, a small startup, really just getting started, and how Java is able to help them. So please help me welcome Clement, who is the co-founder of Wavefront.
Thank you, George. Nice to see you.
Good to see you. Welcome. Okay, so why don't you start off, maybe some of the folks in the audience have not heard of Wavefront yet. Why don't you tell us a little bit about you and what you do?
Sure. So Wavefront is a 4-year-old startup in Palo Alto, California, that started with a vision that the best way to understand machines, software, and even people is through the power of metrics. And to that end, we have built a massively scalable time series database and a query engine on top of it that allows complex mathematical transformations done in real time. Our customers use Wavefront to detect downtime, to find anomalies, to identify root causes, and to discover solutions to their problems. We've had some amazing partners along that journey, and I can say it has been a blast so far.
Great. So why don't you tell us a little bit about the architecture?
Sure. So as a SaaS company, Wavefront runs a collection of microservices in the cloud, which collectively delivers a web-based UI for interacting with data. The core engine consists of data ingestion services fronted by collectors that takes in customer data from agents, proxies, and external sources. It also handles the planning and parsing of queries written in our unique time series language and executes them in a parallel streaming manner.
Okay, great. So I think folks in the audience would love to hear why was Java a choice for you, and why did you choose it?
Sure, why Java? So we started with Java because of the maturity of the ecosystem, and which allows us to stand on the shoulder of giants as we develop the product. Our microservices are built on top of Drop Wizard. We have dependency injection by Juice, Jackson, Jersey, RPC with Avro over Netty, HTTP serving with Jetty, Mustache. I mean, I could go on and on for the next 10 minutes probably. But all of these libraries are mature, well-documented, battle-tested, which enabled us to write our product and develop our ideas instead of spending a lot of time to lay out the groundwork. We are also big fans of Yammer metrics and a lot of the libraries that are out there, such as Google Guava, Apache Commons, and probably a lot of the primitive collections libraries out there. The Java language itself, especially the innovations that we have seen in the last couple of years, have really enabled us to write code that's easier to read and also less error-prone. I never thought Java was a verbose language. I guess we all use IntelliJ at work. But I think with the introduction of lambdas, stream processing, and the default methods, to name a few, has really enabled us to write code that is more elegant than ever before. On the JVM side of things, no doubt the massive investments and talent, which many are here today, is a major reason for why we chose Java in the first place.
OK, great. Well, thanks very much.
Thank you.
And best of luck.
Thank you.
OK, I thought it was really neat to hear just a couple of stories from different places on how people are using Java. I did want to just sort of close my section with telling you a little bit about what you can do now. If you haven't already, please upgrade to Java 8. You'll really be glad you did, so please do that. And then the other thing is I wanted to mention that many of you are aware, many libraries and frameworks folks out there, as well as many application developers, have already downloaded the early access builds of Java SE 9. Had a look, tried to make sure their applications or their code is running smoothly on it, and reporting issues through the appropriate channels if you run into any issues. So please do that. Now, in order to take the next step here, what I'd like to do is invite the chief architect, Mark Reinhold, to come up on stage and give us more technical details.
Thank you, George. Good afternoon, and welcome to JavaOne again. Here we are. So it's been a really busy year for Java SE and the JDK and everybody across the ecosystem who works on it. I'd like to take some time to talk about what we're working on for the near future, the sort of medium term, and then the longer term with help from a couple of my colleagues. So first, of course, the near term, everybody is focused on Java SE 9, JDK 9, which will be coming soon, maybe not as soon as you had hoped, but it will be coming soon. There are lots and lots of features in 9. You may think that 9 is all about jigsaw and modularization. Well, no, there are actually many, many more features than that. Here's the complete list. 85. Some are big, some are small, some are related to each other, some are standalone, some are really teeny, but extremely valuable. So I'd like to start by showing you just one of these, and that is JShell, the Java read-eval print loop. I would like to show you JShell. The JShell is the interactive Java shell. So I'm running a recent Java 9 build here, a very recent, just a few days old. Let me start up JShell. So JShell is an interactive shell. It's a program you can type snippets of Java code into, and it will evaluate them and print the results and show you what's what. So I can type, for example, a simple expression. OK, well, that's reassuring. Arithmetic works. I can declare a variable. 42. OK, I can write a little statement. Let's write a little statement. Trivial, I know, but there it is. Then if I look at I, it's now 50. And behind the scenes, this is using the compiler API to take these expressions, evaluate them in real time, compile them to bytecode, run those bytecodes, and show you the result. So far, I've shown you fairly simple things. What's extremely cool about JShell is you can use it to explore an API. So let me make a string. String x equals everybody's favorite string, foobar baz. So I've got a string. This variable x is referring to the string object. I can now ask, what methods can I invoke? JShell, like most self-respecting shells, has tab completion. I type tab here, and boom, it shows me all the methods I can invoke. Now, some of these are overloaded. So I can go further. I can say, let's see, there's got to be a substring method, right? Yep, there's a substring method. That completes. And if I type shift tab here, it shows me there are 2 overloads of this method name. There's one that takes 1 int, and there's another that takes 2. And of course, I can invoke those. I can do this, and I get that substring. I could do this, say, substring 47, and I just get bar. And as you can see, there's complete history here. It saves everything over time, so you can go back and refer to previous snippets. Oh, the scaling's off. I'm sorry. Let me correct for that. OK, so I can do even more than that. So remember, I've got my string x. Let's say I want to split that on spaces. Oh, now I've got an array. And well, JShell could be more helpful at printing this out. So what I'll do is I'll just convert this to a list. And I see I've got the list of strings foo, bar, and baz. I can do more sophisticated things. You notice these numbers, the $10 and so forth that's shown here. That's a temporary variable. I can use it to refer to the value of a past expression. So for example, $10, that's this list. What's an interesting method on list? Well, I can ask for a stream. I could then filter. Say I want to get all the strings out of that list that start with the letter B. So I write myself a little lambda expression. Starts with, and you see it's doing completion even in the middle of this lambda expression that I'm typing in this complex statement. So it starts with B. And then I want to collect that into collector. But now it's not completing. And the reason it's not completing is it doesn't know about the stream package by default. So I can fix that by doing an import. JShell imports a number of packages by default, but not Java util stream. I import that, and now it will offer to complete that on collector. I can say collectors.toList, close that out, and I will get the list of strings bar and baz. So JShell is all about exploratory programming. You know, all those annoying times when you have a question about, well, is this thing going to work in this certain way? Sure, you could go read the spec, you could go look it up on Stack Overflow, but sometimes it's easiest to just create an x.java file and compile it and run it. But JShell takes the tedium out of that. You can just drop into the shell, do some exploration, figure out how something works, and then move on. JShell is what's known in older languages as a REPL, R-E-P-L. It stands for read, eval, print loop. It's something that's been in Lisp systems for years, and as an old Lisp guy, I'm very pleased to see it come to Java. It's also a great complement to IDEs. NetBeans 9, in fact, the early builds already have support for JShell. You can type JShell into a NetBeans window and then automatically convert snippets into your actual code. OK. Enough on JShell for the moment. Not sure how this is going to work. I wasn't expecting a reboot. OK, let me talk about Project Jigsaw. It is, after all, kind of the headline feature of the release. So Jigsaw. Define a standard module system for the platform, apply it to the platform itself. With a number of really important properties we're trying to achieve. One is that it be approachable, something that everybody can use to write large applications and large systems so that you can escape from class path hell after all these years. We need it to be scalable. It can't just be a toy. It has to be something that's capable of modularizing the platform itself. And finally, it has to be compatible. We can't modularize the system and say, oh, well, all that old code, all those systems you have running now, you have to go do a bunch of work just to make them work. No, if something works today, it should work tomorrow, by and large. So this is a fairly hard problem. We've made a decent amount of progress, and we've come pretty far. The proposed design gives you two key values from modules. One is reliable configuration, because a module names the other modules upon which it depends. And the other is strong encapsulation, because a module specifies in its self-description exactly which packages it exports and which ones it does not. So it's a fundamental new kind of program component wired deeply into the Java virtual machine and understood in the programming language. It's not a library or a framework that's just kind of built on top of Java. So if we drop back into JShell, we can actually see some of the effects of this system. Let me get my foobar baz string back here. So now I'm going to do a little bit of reflection, right? So x is a variable referring to a string object. I can ask, what is its class? And sure enough, I get Java blank string back. That's what I expected. And now I can also ask, what is its module? Because every class is in a module. And the module is a module called java.base, the base module that contains the fundamental parts of the system, Java lang object and string and system and all the things at the very core, but certainly not all the rest of it. If I look at some other class, let's make a Java SQL timestamp just at random. Okay, so there's a timestamp object. I ask, what is its class? I get timestamp, and I ask, what is its module? And I get java.sql. The JDBC classes, they're not in the Java base module. They're in the java.sql module. There's a separate module containing that content. So dropping out of JShell, if I type Java list modules, I get, whoa, a list of all the modules. There are a lot of them. How many are there? There are 72 all told. I can try to format these a little more nicely. There's a decent list. There's the rest of the list. So lots of stuff here. Guess what? It's easier to look at in graphical form. So let's do that. So here is the module graph for all of the Java standard modules in the system. Now, you might notice this looks a little bit cruder than the hand-drawn graphs I've carefully constructed before. And that's because this graph is actually generated by the JDK build. Part of the build process, it generates dot files, which we can then render into pings that are a completely accurate description of the modules in the built image. Now, as you can see, the base module is down here. It's the only module that it depends on no others, and every other module depends on it. And then we've got all these other modules up here. Up here, for example, is the SQL module. Okay, so it's a pretty big change to take a monolithic system and modularize it and impose this kind of structure on it. What does that mean for existing code? Well, existing code, by and large, just works. I happen to have here a copy of Swing Set. Anybody remember the Swing Set demo? So this is the actual Swing Set 2.jar file from JDK 5. And look, it runs. No problems. I used to love this demo. It was great. You can go look at the, oh yeah. Here are the famous bouncing babies. I mean, these kids are like in college now, right? So in general, if an application uses only the standard Java SE APIs in 8 or earlier releases, it will just run on 9. Now, there are a few extremely rare exceptions, but we have not run into many actual applications or libraries that run across those exceptions. Now, what I said about only using standard APIs is critical, because now most JDK internal APIs are strongly encapsulated. If you have code that's going into, Sun AWT X11 or something, guess what? It's not going to work, right? We've encapsulated the internal APIs of the JDK for 2 reasons. One is to improve security, and the other is to improve integrity so that it's easier to evolve the platform over time. As things stand, we're kind of stuck when we want to evolve things, because we always have to think, oh, we're going to break somebody because they're using an internal API, which they shouldn't have been, but we don't want to break them, and so what do you do? Okay. I'm sorry, I'm trying to figure out what to do with my remaining time. So we've got the module graph. And that means we don't have to carry everything around. If an application only needs a few things, we can make a custom JDK, a JDK that just contains the modules that we need. So there's a new tool called JLink. I can tell it where my modules are. And I can ask for it to generate me a JRE that contains just what I need. Now it's complaining because I didn't tell it. I have to tell it what I need. So let's make a teeny runtime with just java.base. Add modules, base, output JRE. It goes off and thinks. And now I have, if I look at JRE, it's a JRE plus JRE bin. It only has a couple of commands in it. And if I run it, I can ask what modules are in it. And it's just the base module. I can ask for more details about base, and it'll show me all of the stuff that base exports. So as you can see, there's quite a lot of good stuff here, IO and Lang and math and net and NIO and security. So you can do a fair amount of stuff with just the base module. Now, you can also make it smaller, even. So here's the full JDK, 505 megabytes. That JRE I just made is 46. I can give JLink some magic options. Let's say strip out the debug symbols. I can use a special small VM. I can compress all the class files even more. And I can make a small JRE. This takes more time. And that small one's only 17 megabytes. So this is Linux x64. On something like Linux ARM32, it would be smaller still. So the JDK itself, of course, is built with JLink. That's how we build the entire JDK. It's just JLinked with all of the modules of the system. And you can also include your own modules in a linked image. So if your application consists of modules, you can link those all together into one image, stick it in a Docker file, and deploy it to the cloud, and off you go. So there's a little bit more I wanted to say, but I'm running out of time. I apologize for that. So Jigsaw has been this big effort. It's still going on. There's still a lot of work to be done in both the JSR and the design of the module system and in the expert group, and also, of course, in the implementation. So we're continuing to work on all that. We could switch to the other machine, please. You can learn more about Jigsaw this week. My colleagues Alan Bateman and Alex Buckley have put together a number of sessions. I'll be in most of these too, ranging from fairly introductory, prepare for JDK 9, all the way through a hack session where you can come and ask questions and hack on code. Other information is available on the Project Jigsaw webpage. Almost everything is documented in a series of JDK enhancement proposals, and also, of course, in the JSR for the module system itself. So, to look a little further into the future, I'd like to welcome Brian Getz, our Java language architect.
Hey, Mark.
Hey, Brian. So what have you been cooking?
So, for the last couple of versions, we've been focusing mostly on big stuff, Lambda and Jigsaw, and that stuff is important. It's building the foundation for the future. But we also care a lot about everyday developer productivity. And so I want to talk about a couple of features. I want to talk about a couple of features that we're looking at in the short term that are just going to make developers' lives easier, every day. So, are we good? OK.
That's actually what we want.
So we want to take a targeted look at some of the biggest sources of boilerplate in everyday Java coding.
I hate boilerplate.
We all hate boilerplate. I'm sure if we took a survey, the audience would agree with us, right? And a lot of it is unnecessary. And so one of the biggest offenders in terms of boilerplate is just writing ordinary domain classes, like the one we have up here in XY point. And it would be nice if that was the whole class, because that's really all the semantic content. But unfortunately, that's not the whole story. We have to have a constructor, and you really ought to have an equals, and you really ought to have a hash code, and to be polite, you really ought to have a toString. And what's unpleasant about this is all very low-value code. It's work to type and it's work to read. And maybe the IDE is going to generate it for you, which is great, but you still have to read it. And the IDE can't really help you in the reading of it. And as you know, one of the core language design values of the Java language is reading code is more important than writing code.
Indeed.
So we want to make these classes easier to read because people can look at it and say, I know exactly what's going on, and not have to work their way through all the boilerplate. And so it would be nice if there were a way to say, I'm just a dumb data holder class. Here are my principal fields, and let the compiler generate sensible implementations for all of those artifacts.
So that's cool, but what if I don't want my own equals method or something?
Then just declare it.
Do that?
And the compiler will see you've got an equals method. I don't need to give you one.
Excellent. Excellent. So what else are you working on?
OK, so along the same lines, we want to expand the scope of type inference. So type inference is where the compiler...
I keep hearing people say Java doesn't have type inference.
Yeah, we've had type inference since Java 5.
Really?
And we've slowly expanded the scope of it, in all those versions. So type inference allows us to remove redundant code redundancy from our code, while at the same time maintaining the benefit of strong static typing. So it's not dynamic typing. It's just not making you do the finger typing to get the type theoretic typing. And so, in Java 5, we have type inference to infer the type arguments of generic method invocations. In Java 7, we extended that to generic constructor invocations with the so-called diamond syntax. In Java 8, when we did Lambda, we also provided for being able to infer the types of Lambda formals. And we think the sort of next logical place to apply this approach is in local variables, where you can infer the type from the initializer.
No, hang on. Are you turning Java into JavaScript here?
Absolutely not. This is still strong static typing.
Good.
It's just that the compiler has already figured out that this thing is a buffered reader, and you don't have to tell it. Now, a lot of people freak out when they see this because they think, oh my God, the code's going to become unreadable. And it's certainly possible to write unreadable code. But if you've picked sensible variable names, when you take the static types away from these locals, the code actually remains pretty readable. In fact, you might argue it's more readable because you're getting immediately to what does this thing represent in my program.
OK, very cool. Now, you've been working on some even bigger picture things, too, right?
Absolutely. So, these are little things. They're great. We want to get those out where they're going to make people's lives better. But we've been focusing a lot of energy on two major projects, which we talked about last year, Projects Valhalla and Panama. And Project Valhalla is about value types and specialized generics over values. Now, value types are like programmable primitives. They have all the expressive and safety benefits of classes with the performance of primitives. And then at the same time, upgrading generics so that you can specialize generics over values and primitives so you don't pay the performance penalty of boxing. And this is really, really cool. And then the other big project that we're working on is Project Panama, which is about rebooting the interaction between Java and native code and data. So you can call C functions can call back to Java, you can access data right out of the native heap without marshalling it into the Java heap.
And having to write all those stupid JNI stubs. I hate writing JNI.
Yeah, that's all a thing of the past. So you replace this complicated, handwritten, error-prone JNI process where you have to write all of this C code with a tool that just, you point it at the header file, it generates everything for it, and you use it like as a Java API, and it's safe and it's fast.
OK, and you're having fun.
Oh, so much fun.
Excellent. OK, thank you, Brian.
Thank you, Mark.
So in closing, I'd just like to reiterate what George said. It's a fundamental importance to the quality of the platform and its implementations that we get your help. Please go to jdk9.java.net, download the binaries, run your old code on it, test out the new features, and let us know what you think. The feedback we get is just priceless. Thank you very much. Have a good week.
Ladies and gentlemen, please welcome Anil